Hello, everyone. I hope you're doing well and that you enjoyed the last module where we kind of recapped everything that we've covered so far in terms of looking at relationships between two variables. We also learned how to replicate some of that using AI, which is going to be a powerful tool for you in the future. For this week's module, what we'll be covering is multivariate statistics. Simply put, multivariate statistics are when you run a model like we've been doing, but instead of using just one predictor or one input, we're using multiple inputs. So you have multi-inputs, and thus you get this multivariate statistics. And there's some really neat things that happen when you run a model with multiple inputs at the same time. To help illustrate this, we're going to be using the macaroni survey and data set. This is a survey for a macaroni restaurant company. So I've downloaded the survey and the data set. I'm going to just load those now. I'm going to create a new project. We've done this several times in the past, so you should be pros at this by now. I'm going to go to survey, and then I'm going to click Get Started here down on the right. Next, I'm going to name the data set whatever I want. For me, I'm just going to name it macaroni survey. Sure. I'm going to put online for my online class. You can name it again whatever you want. And then instead of creating a blank survey, I'm going to import a QSF, choose a file. I'm going to go to downloads, and I'm going to select macaroni survey file, click open, and create project. Now, before I give you a little intro to this, let's load the data so that can be revving up as we go through. So I'm going to click Data and Analysis up here. Let this load for a second. And now I'm going to go to Import Data, choose a file. I'm going to select my macaroni data, open it, upload, and then import. And that'll start loading for us, all right? So while that loads, let me pop back over here on the survey and I'll introduce you to it. So the idea is that we have a macaroni company called the Mac Shack, and there's several locations, all right? And this survey has been sent out to customers afterward. We have satisfaction with the music, satisfaction with service, satisfaction with food, their overall satisfaction, whether or not they plan to visit again. And also we have NPS, and I've talked about this one before. This is Net Promoter Score. This is the crown jewel of all survey questions. I'm obviously being sarcastic here, but I thought I'd include it here. Typically, though, traditionally, this is like a 10-point scale. So we'd have 10 items here. I just feel like that's a lot, and I wanted to keep things consistent. So we just have a 5-point scale for all of these items. And then if we come over here to the survey flow, we have another variable here called location that tells us which location each participant took the survey from. I think there's like location A, B, C, and D. Okay, so pretty simple and straightforward. I'm going to pop over here to see how my data is doing in data and analytics. Okay, it looks like we're all revved up and ready to go. So I'm going to click Stats IQ to get that rolling as well. And this, again, can just usually take a couple minutes to load. All right, so now that is loaded in Stats IQ, I can see here that here we have a number. Got the 1, 2, 3. So we have number. This is whether or not they plan to visit again. So here's a category. We have a number for NPS, and location where they served. That's going to be a category as well. Now, as I go through and teach you how to do multivariate statistics, we can open up the assignment for this module, multivariate statistics. Here's the scenario as we already described, the survey and the data. Now, the multivariate overview table is going to differ just a little bit from the last overview table we used when you just have one predictor. In this case, for our input, we're going to have multiple inputs here, all right? And if there's at least one category input and our output is a number, we're going to be doing an ANOVA. But this ANOVA, you'll see, it'll look a little different than what we've run before. The metrics, we're going to have betas. Actually, we're going to have betas and p-values for the metrics on all of these analyses. So these become our primary metrics. And so just keep that in mind. If all of our inputs are numbers and our output is a number, we're going to do linear regression. If our output, though, is a category, it doesn't really matter what our inputs are at that point when we have multiple predictors. They could be all numbers, they could be all categories, they could be a mixture of the two. It doesn't matter. We're going to do a logistic regression. All right. So just bear that in mind. We'll be running through this as well. Stats IQ will automatically run the right analysis for us. AI tends to do that as well once you've described the data properly. But we'll run through what each of these look like as we go through this module. So for question number 1, I want to start just with a recap to kind of help us visualize what's going on when we have multiple predictors. So for this first section, we're going to be looking at whether satisfaction with food predicts overall satisfaction. So if I pop over to Stats IQ, I can run this analysis. We've done it before in the past. You should be pros at this. We have satisfaction with food and overall satisfaction. Now think which one is our input and which one is our output. If I'm looking at whether satisfaction with food predicts overall satisfaction, overall satisfaction is that final output, the final destination. And so, and I want to see if I can predict it with food. So the predictor is always the input. So I know that Q3 is going to be my input and Q4 is going to be my output. So taking that into account, the key should be on my output. So I have overall satisfaction and I click relate. And again, we should be able to do this quickly. I click here. Here's my beta. It's 1.12. My p-value is below 0.00. How many zeros do we have here? 0.0001. Okay. It's going to be a really low number, far below that. If you're putting in the answer, just, you can double click to highlight, just copy and paste the answer here. You don't have to include the greater than or less than. But I want to introduce another measure that we haven't had so far, okay? This measure is right here, and it's R squared. And R squared, pretty much what it tells you is it's the percentage of our output that can be explained by our input. So in this case, you'd say, okay, there's about, if we round it, about 78% of overall satisfaction can be explained by satisfaction with food. So let's say that this pie here is our overall satisfaction. And what we want to do is we want to figure out, we want to build a model to see how much of this satisfaction can we predict. And when we run food, we find an R squared, forgive me, the rounding's a little off, but the R squared was 78%. And so we find that overall satisfaction, about 79% of it can be explained by their satisfaction with food. Now let's run this again, but let's use satisfaction with service as our predictor this time, and click relate. Okay, so we're going to find our beta here, our p-value there. It's a positive beta, so as satisfaction with service goes up by 1 point, we'd expect overall satisfaction to go up by 1.13. And here's our R squared, so it's 68.5%. So 68.5% of overall satisfaction can be explained by satisfaction with service. Now here's a struggle here. The struggle is that when we ran food, about 23% of it was still unexplained, okay? But when we ran service alone, about 32% of it was left unexplained. Now, the problem is the math doesn't add up. If we're explaining 77% of satisfaction with food and then 69% of it was service, that doesn't quite add up. There's only 23% left here, not 69% that we'd see in service. And so obviously, either the math is wrong or there's something else going on that isn't being accounted for. Now let me take a look here just with one more thing. Let me try music really quick, because this goes with a story that from my personal life that relates really well to this. So for music, we're seeing a positive beta, positive p-value. There's less though. There's like 34% that is explained by music. Now, if any of you have been to Via 313, it's a great pizza place. I really like it a lot. But they've adapted their music since the first time that I went. I went there with some colleagues just when it opened, and I didn't have a very good experience. And the problem was that it played like hardcore heavy metal music the entire time, and it was just like pounding in our ears, right? It's not the typical restaurant experience. It's not music that me or my colleagues really enjoyed. And as we left that restaurant experience, we were even just talking about it as we left, and I think that the manager was actually outside transferring some things in our car. May have heard us talking about this music and how dissatisfied we were with that experience. Now, if you think about that satisfaction with music, do you think that negative experience bled into our satisfaction with other items? Say, for instance, maybe because of the music, I didn't like the food as much as I would have had the music been better. Maybe I would have been more satisfied with the service and left a better tip had the music been better and more relaxing. Even though, like in reality, that any negative experience I had may have been due to the music, it kind of bleeds into other aspects of the overall experience. As a professor, I see this a lot with SRIs. So let's say that a student doesn't agree with how I graded an assignment or something like that, and they're very, very dissatisfied with that experience. And they go to rate the course, and even though it's that one assignment and that one experience they're dissatisfied with, all of a sudden they hate the whole course. They hate what I taught, how I taught it. They hate how the course was organized. They think I'm dishonest or whatever, right? It just all kind of bleeds through. And they could have had like a good experience overall, but that one experience kind of tainted their perception of the whole course, and it came out in the review. Something like that could very well be going on here. If I'm dissatisfied with the service, or I'm very satisfied with the service, that can bleed into food. My satisfaction with food. And so even though food is about 77% of overall satisfaction and service is 69% of overall satisfaction, there's a lot of bleeding between food and service. And so what would be awesome is if we could find a way to build a model where I could see what the impact of their satisfaction with food was, while also subtracting the impact of satisfaction with service. If I could just say, okay, let's take their satisfaction with service out of the equation per se, so it's not bleeding into their satisfaction with food. Or say, for instance, in my Via 313 experience, how would my satisfaction with the pizza, how would that have influenced my overall satisfaction if music was like, if we could take that into account and we could pull that out of the equation, so we're just looking at my satisfaction with food and overall satisfaction, just that relationship. If we could hold the music constant or hold any of these variables constant and separate them, what would things look like at that point? And that's exactly what multivariate statistics gets us. So let's try one with this experience, okay? What would happen if we ran service and food at the same time in the same model? Question number one, like what percentage of overall satisfaction would we be accounting for? And what would be the biggest predictors? Would it be food or would it be service? Okay, we can't quite tell that at this stage. So I'm going to pop up over here and I'm going to have service and food. I'm going to select both of these as my predictors. But instead of clicking relate, I'm going to click on regression. And this will run both of these together in the same model. So as I click this, this is nice. It tells me that they both are similarly strong predictors. So we'll always get a nice sentence, which I like with Stats IQ. Now, how important each predictor is will be displayed here. So you have satisfaction with food has a 56% importance rating, and satisfaction with service has a 44%. And right here, you see this is our R squared, and you see that it's 79%. So whereas food on its own was 77% and service was 69%, if I run them both in the same model, then we have 79%. Okay, so really it's a little bit more than what food was when we take service into account as well. We're not really upping the R squared very much. We're only accounting for 79% of overall satisfaction, which is still a pretty good chunk. However, when we look at that 79%, it can be broken down in the following way. Food is 56%, so you can see that here. So of the 79%, 56% of it comes from food, and 44% of it comes from service, right? So if we're adding up this whole thing as 100%, service is about 35%, food is about 44%, and we're left with 21% unexplained. Now, when we come here to explore the model in detail, right here, these are going to be our betas, and these are going to be our p-values. And you'll see that the betas and p-values look different than when we ran each predictor individually. The betas are both positive. So food, we have 0.62, and service, we have 0.59. Now, the way that we look at these betas is just a little bit different. It's still a positive beta, so we'd say as food goes up by 1 point, we'd expect overall satisfaction to go up by 0.62. But there's a caveat, and the caveat is while taking into account their satisfaction with service. Anytime that we're running multivariate statistics, when we're looking at betas or p-values, anytime we report those findings, we're going to then finish off the statement by saying while controlling for or holding constant any other of the predictors that are listed. So we could have service and music and location and run all of those at the same time, and we'd say, okay, the satisfaction with food, its beta is blank and its p-value is blank, while holding together satisfaction with service, location, music, whatever other predictors we've included, okay? In this case, we've only included one other predictor. So the beta for satisfaction with food is 0.62 while controlling for satisfaction with service. So this satisfaction with food, what we've done from that initial example I gave you, we're able to pull out satisfaction with service so that they are no longer bleeding together, all right, which can be very, very useful. And then for satisfaction with service, we could do the exact same thing, just flipped around the other way. So the satisfaction with service, its beta is 0.59 while controlling for satisfaction with food. And its p-value dropped down quite a bit. And you can tell that because this p-value for satisfaction with food is still so high and it dropped a bit for service, it's still significant, but it dropped a bit for service, you can see that satisfaction with food is turning out to be the more important predictor. And so if I had to choose between, okay, how much I can put a lot of money into my food or I can put a lot of money into my service, I can say, okay, well, satisfaction with food in this case seems to be the more important predictor. So let's up the ante. Let's put our money where we can get the most bang for our buck. And so now that we've done those two, and by the way, these are all numbers. So we're doing a linear regression. As you can see here, they're all numbers, and we have a number here. We're doing a linear regression. Let's add music as well and see what this does. So now we have three predictors They're all numbers, so we're still going to be doing a linear regression. Let's click regression and see what we get. Okay, so you can tell here what is the most important predictor? Satisfaction with food. Music seems to be the smallest one. And you look at R squared, it bumped up to 79.8. So we're about 80% of overall satisfaction is now explained by this model. And we can explore it in detail. And what we see here is still a significant p-value for food. They're all positive betas. You see that all of them are significant predictors, but one is really standing out, and its satisfaction with food makes complete sense. So you could say, just as an example, as satisfaction with food increases by 1 point, you'd expect overall satisfaction to go up by 0.51. And that's while taking into account or controlling for satisfaction with service and satisfaction with music. Then we can say, okay, for satisfaction with music, as that goes up by 1 point, we'd expect overall satisfaction to go up by 0.28. That is a significant relationship, and that's while controlling for satisfaction with food and satisfaction with service. And so really what you're getting is 80% of this model, overall satisfaction, can be explained by these three predictors. Okay, of that 80%, 48% comes from food, 29% comes from service, 36% comes from service, and you look here at satisfaction with music, that ends up being 16%, okay? Or if you're looking at as a whole, the 100%, music accounts for 13%, service 29%, and food 38%. So food is the most important predictor between the three. So now what I want you to do is include NPS as a predictor, run the regression, and tell me what you find. What's the most important predictor? What's the least important predictor? Where does NPS rank up? Now that we've done that, let's look at what happens when we add a category into the equation. All right. So if a category is right here, if a category is included, then and our output is a number like we have here, then we're going to be running an ANOVA, and it's just going to automatically do that for us. All right. So I have location here, but actually instead of location, let me start with something a little bit more simple. So whether or not they plan to visit again, yes or no. I'm going to click regression. And here you see our R squared popped up more. That's nice. And I pop down here, this will kind of correlate with what we see here. Food is the most important predictor again. Satisfaction with service, then plan to visit again, and then sat music. Now let's look here at plan to visit again. All right, and you'll see here that there's this one p-value, and the p-value is on the no row. And now what this will do when we have a predictor or an input with two categories, it's going to choose one of those categories as a baseline, and it'll tell you what will happen if you move from that baseline to the other category. So in this case, it chose yes, they plan to visit again as a baseline. And what we're seeing here is if they move to a no, then overall satisfaction dropped. This is a negative beta. So if, again, just to reiterate, by moving from a yes to a no, their overall satisfaction dropped, which makes sense. If they say, no, I'm not coming here again, chances are their overall satisfaction was lower. All right? So, and that beta, of course, is while taking into account these other variables here. Same with this p-value. Now, what's cool is I can choose my baselines. So you may say, this doesn't really make a lot of sense in this model. Let's just say that I don't want yes as my baseline. I want no as my baseline. So I can click that and click apply. And then what I get here is, you notice this is the same beta that we had before, but now it's positive because now no is my baseline. So what I can say, okay, as they go from no, I won't visit to yes, I will visit again, that predicts that satisfaction, their overall satisfaction went up, and it went up by 0.65 points. The p-value is going to be the same, the beta is going to be the same, it's just going to switch signs from positive to negative. So let's try another one just for kicks. I'm going to have NPS as my output. I'll still have everything else there, but just swap my outputs. So my output is NPS. I'm going to run that, explore the model, and here, plan to visit, that this is lower. It explains 11% of NPS, right? The p-value is not even significant. So whether or not they plan to visit again did not significantly predict NPS, and that's while holding constant all of these other variables. Okay, which is interesting because if I just ran this alone, plan to visit again, and I ran relate, it's going to do a t-test for us, and let's see if it's significant. It is very significant. So if you're only looking at plan to visit alone, it significantly predicts NPS. But if you include these other variables, they are better predictors of NPS. And so what you're getting here is once you include those, plan to visit no longer significantly predicts. Okay, and let's say I want to use my baseline as no. You'll see that this beta will stay the same. It'll just switch signs. And just switch signs like that. Okay. So let's say that this was significant. It's getting there. It's a fairly low p-value, but it's not marginally significant. It's not significant. But let's say that it was. What we'd say is, because the baseline in this case is a no, then we'd say as we move to a yes, so if they say that yes, they're likely to visit again, then we'd expect overall satisfaction to increase, to get higher. And that's while controlling for these other variables. So let's try another one. Now, instead of plan to visit, let's include location, which has 3 categories. You have location A, B, and C. And let's first, just for fun, see what this is alone for NPS. And so I see that there is a statistically significant relationship. I have a p-value that's pretty low. But remember, with ANOVAs, this p-value doesn't necessarily tell me that all of these locations significantly differ from one another. For instance, if I'm looking here, I see, okay, location B has a 3.07. Does that significantly differ from second place? I don't know. We could probably guess it significantly differs from the last place, because that's a pretty significant p-value, but we still can't be for sure until we click here on the pairwise comparison table, and we see that, okay, location B and C, those significantly differ, but the others don't significantly differ from one another. So we see, okay, B and C, the highest and the lowest, these do significantly differ, but location A is somewhere in the middle, and it doesn't significantly differ from B, and it doesn't significantly differ from C. Okay, that's just a recap. We've done that before. But what happens if I add satisfaction with music, service, and food? Let's see what happens there to that relationship. Okay, so if I add that relationship, location doesn't really even seem to be coming up. Hey, look at our R-squared though. That's pretty good. Pop over here, and we see that location is not significantly differing at all. Okay, but the thing is, now we have 2 p-values and 2 sets of betas. So before, when we were looking at whether they would visit again, we only had 2 categories, but now we have more than 2 categories. So it's going to choose a baseline just like it did before, but it's going to compare the other categories to that baseline. So this p-value here is giving us the p-value between location B and A while controlling for these other variables, right? And this p-value here is giving us the p-value between A and C, because A is our baseline, so A and C, while controlling for these other variables. If I want to change the baseline, so say I want to be like, okay, I know what, I got a p-value for between B and A, I have a p-value between A and C, but I want a p-value between B and C. I want to see, okay, does location B and location C, do those significantly differ? All I'd have to do is choose one of them. It doesn't necessarily matter. I'll choose location B and click apply. And then once that's loaded, I can now look at, see, B is my baseline. I can now look at C and see, okay, yeah, that's still not a significant p-value. Now these betas in this case are both negative, okay? So I'd say as we move from location B to location A, it drops. So they have a lower NPS for location A than location B, and they also have a lower NPS for location C than location B. All right. That, of course, that's not significant, so we're just kind of trying to understand this beta a little bit more. But that's how we would look at this. I could choose a baseline, any of the baselines. Let's try location A again. And here I'm seeing a positive beta for B because B is higher. There's a higher NPS for those at location B than A. And then here, location C drops. So location C seems to be lower than location A. Let me try a different output. Let me go to overall satisfaction and run that one. Oops. Newbie mistake, I forgot to push the key. Now let's try it. Okay, so here we go. I've run this, and okay, there's more going on with location. All right, we have a significant here. So look at my baseline, it's location A. So there's a significant difference between location B and location A. That's good. We have a positive beta here. So B is higher than A. And here, this isn't quite significant. It's 0.07, but it's marginally there. We could see that location C is marginally higher because this is a positive beta. It's marginally higher than location A. And I can choose whichever location I want. Let's say location C. I want to use that as my baseline. Click apply. And if I do that, I see that, okay, there's no significant difference between B and C, but there's a marginal, we already saw this, but a marginally significant difference between A and C. So I hope that makes sense and that helps you there. Now, lastly, let's take a look at logistic regression. So we're going to get logistic regressions if our output is a category. It doesn't really matter. You can have any combination of our input, but our output is a category. So let's start with plan to visit. That's a category. It has two categories, which is going to help us. I'm going to just select these three as my input, so Q1 to Q3, and plan to visit Q5 as my output. I'm going to click regression. And here I'm going to get my R squared there. It's a little bit lower. We're having a harder time predicting plan to visit. But we pop here and we see, okay, we only have one significant predictor, satisfaction with service. Now, here's the thing. P-values, those are easy, but betas. Now that our output is a category, we have whether they plan to visit, yes or no. Okay, And that makes it difficult for this beta. What does a positive beta mean, or a negative beta? What does that mean in this case? And similar to what we were looking at in the last examples when we're running ANOVA, what Stats IQ is going to do is it's going to separate them, but instead of choosing a baseline, it's going to choose a target. Okay, so it's going to say, okay, this category is your target. And what the betas are going to say is, okay, as your predictor goes up, what's it going to do to the likelihood of the target occurring? So in this case, our target is yes. So this is a significant p-value. Our beta is also positive. So it means as satisfaction with service goes up by 1 point, it increases the likelihood that a yes happens, the target happens. So they would visit again. If I pop down here and click on no and click apply, you're going to see similar betas, but now they're opposite signs, because as satisfaction with service goes up, you'd expect the likelihood that they don't visit again to go down, right? The more satisfied they are, the less likely it is that they don't want to visit again. Now let's run, just for kicks, let's throw a location in here and click regression. So now we have a categorical input that we're including into this model. We see our R-squared here, satisfaction with service. That seems to be like the main predictor in this case, which is fun. Okay, we run this. We see there's a satisfaction with service is a significant predictor, but we're also getting something going on here with location. Okay, so for here, the location, the baseline is A. So we can see that between location A and B, there's B is higher. Okay, so what does that mean? This is kind of getting a little crazy, but look at our target. So our target is a yes. So a positive beta means that there's a higher likelihood that they say yes, they do want to visit again. All right. So for B, we have a positive beta. So for location B, they're more likely to want to visit again than our baseline location A. But there's no difference in the likelihood that they want to return between location C and location A. Let's say I want to look at to see if there's a significant difference between B and C. I could select one of those, either one, and click apply. And I go to the C and I see, oh, okay, that's not significant. B is still significantly different than A, but there's no significant difference between B and A. But again, for A, now we're getting like the opposite sign here. So I see that there is a significant difference between B and A, such that as location A has a lower likelihood, this is a negative, they have a lower likelihood to want to visit again, this target. I could switch the target to a no, and I'll get the same betas, just different signs once that pops up. So I hope that that's making sense there. It can be a little tricky, but with some practice, you can get a hang of it. So now that we've done that, let's take a look at what happens when our output has more than 2 categories. I'm going to deselect plan to visit, include location. We have this as my key now, so that's my output. Click regression. And here I see, oh, music seems to be, so now what we're trying to do is we're trying to say, okay, can we predict location? Can we predict which location they were at based on their satisfaction with these items? And we see, there's not like a whole lot going on here. They explain a low proportion of location, whatever. Let's dive into this and see what's going on. We're not seeing any significant p-values. Let me include all of these and see if that makes any difference. So I'm going to include all of the numbers. And I am getting one significant p-value, overall satisfaction. which is fun. So let's look at this. All right. So overall satisfaction has a significant p-value, and here's the beta. It's a negative 0.1885. Now, what that means is I got to look down here at my target. The target is a location A. So what this is telling me is that as overall satisfaction goes up, the likelihood that the target happens or they were at location A goes down. So higher satisfaction, it's less likely they're at location A, which is telling me that this probably has a lower overall satisfaction than the others. Let's try a different target. Let's try location B as my target. Click apply. And here I have a significant p-value again, just for overall satisfaction. Again, that's while controlling for all these other variables, right? And here's my beta. It's 1.03, and this tells me that as overall satisfaction goes up, it's more likely that the location is location B. It seems that location B had higher overall satisfaction than some of the others. I'm going to try location C just for fun. And it looks like it did not significantly predict location C. So we're having a harder time predicting whether it's location C. It seems like what's going on is we can see the difference between A and B, and but not necessarily C. So we're having a harder time predicting C. But let's say that these were significant. We'd have a negative beta here for satisfaction with service. So as satisfaction with service went up, it's less likely to be location C. Another negative, these are actually all negative, right? So satisfaction with food, as that went up, it was less likely to be location C. Let me pop back over here to B, see if I missed anything interesting to talk about. No, these are all positive. So for all of these, I mean, only one significant, right? But for all of these betas, since they're positive, as they go up, the likelihood that they were at location B goes up. Let me try A. Now here's some interesting things going on with A. So as overall satisfaction goes up, it's less likely they were at location A. We've already covered that. But let's say that these were significant, these other ones. We have a positive for NPS. So as that went up, is more likely to be location A. Food was more likely to, as that went up, to be location A. Service was more likely as it went up to be location A. Music was negative, so as music went up, is less likely to be location A, right? But those are not significant. But that's helping you get an idea of the betas and how those are working there. Let's include this. So we have all of them together. Run a regression. And now it's going to choose our target down here, but it's also going to choose our baselines here. So our baseline is a 1. So we don't have that significance here with when we're trying to predict location A. But you'd see, let's say that this was significant. So our beta here is positive for a no. So we'd say, like, as they selected no, they're not going to visit again. That increased the likelihood they were at A. Because this is a higher beta for this target. Let's try location B. And we're still not getting a significant p-value. But here there's a negative beta. So as they selected no, they're not going to visit again, it was less likely to be location B. And again, we could go through and we could say, okay, what if I want my baseline to be no? Click apply. And we're going to get that same beta here, but now it's positive. So as they selected yes, it was more likely that they were at location B. Again, not significant, but that's the idea behind it, while holding constant or controlling for all these other variables. So if I wanted to include all of these together and have overall satisfaction, I want to see, okay, how much of this pie of overall satisfaction can I predict if I'm including all of these variables together? And I click regression. Okay, my R squared bumps up to 83.5%. Satisfaction with food seems to be my most important. Looks like satisfaction with service completely dropped off. That one's not significant, which is interesting, right? I would want to put money into satisfaction with food, but maybe satisfaction with service doesn't seem to be doing anything. So if I try to put money into training or other things like that, it's probably not going to give me the most bang for my buck at this point. But NPS, the likelihood they recommend to a friend or relative, that is significant. As NPS goes up by 1 point, we'd expect overall satisfaction to go up by 0.261 while controlling for these other variables, right? Satisfaction with service, again, while controlling for these other ones, it doesn't predict. We have a baseline here on yes for plan to visit. So as they selected no, I don't plan to visit again, they had lower satisfaction. This is a negative beta, and it's significant. Music is marginally significant with the positive beta, so the more satisfied they were with music, the higher overall satisfaction they had. As music went up by 1 point, we'd expect overall satisfaction to go up by 0.19. That's marginally significant while controlling for the others. Location A, this is our baseline. So between location A and B, location B seemed to have higher overall satisfaction. And that's while holding all these other ones constant. But we can't really predict the difference between location A and location C. Let me try using location B as my baseline, B for base. And what I see here is still like a significant difference between A and B. So as location A seemed to have lower overall satisfaction, but there's no significant difference between location B and C. So that should cover us for multivariate statistics, but please reach out if you're struggling. You can always set up a time to meet with me as well by using the scheduler link in the syllabus. I'm always happy to help you figure things out.